All right, hello everyone. I'm really happy to have Emmett with us here this week. Emmett and I kind of go back a few years now through Khronos, and unfortunately, he's recently relocated off to a fun new adventure in New Zealand. And I'm going to let him give his background and intro because he's a really fascinating guy. So, Emmett, to you.
I guess just because my background is weird. Yeah, I'm an aerospace engineer originally. I did my doctorate in control theory, and that's applicable to what I do now mostly because I'm good at vector algebra and filtering. So, yeah, somehow that career wandered through 3D printing and volumetric video to rendering, and that's where I met Mike. I was doing real time rendering on the web. At Google, managed an open source project called Model Viewer, which is still a great project. I hope you use it. I'm not the maintainer of it anymore, but it's solid. And that was based on 3JS, so I was also doing a fair number of contributions on the physically based rendering side of 3JS. And that eventually led to my getting a job here at Weta doing path trace rendering. So that's exciting. New to the VFX industry, but as I say, my career's been through a lot of different industries already.
Yeah, no, that's awesome. And I feel like, yeah, each time you get into that new role, you're like picking up and contributing a lot and mixing it all together. Yeah, I love that when, engineers, especially people in this kind of 3D, AR, VR space, have these different, diverse backgrounds. And in my previous episode, you're talking to Jonathan, he also had like a similar kind of like engineering path. Like, am I going to go this way or that way? And I think it's awesome, especially for folks that are maybe just getting into this and early in their career to realize that like it's not a straight line. Like there's all kinds of interesting like paths that you can take, and each one of those you go down, you're kind of like learn something new and interesting. And yeah, I mean we're excited for you. We obviously miss you, but you're over in the other side of the world in New Zealand and doing some really amazing stuff. I'm sure with Weta, and I probably don't have to say it, but they're pretty well known from like Lord of the Rings. And yeah, anyway, so we're excited to see what comes out of that. Today, I wanted to kind of focus a little bit on some of the Chronos specific things that we had done, and especially a project that you had around PBR neutral tone mapping. And maybe for those who aren't familiar with tone mapping, could you just give us like a quick primer? I know we could spend like hours on it, but maybe a high level, like what is tone mapping and why should you care?
Right, right. I mean, realistically, if you can find anyone who is already familiar with tone mapping, that's pretty impressive because what I found from working on it is it's not a super well known area. Um, yeah, and it's also difficult because there's a lot of terms and a lot of names for these things that are all really wishy-washily overlapping, right? So, like around Weta, we might talk about color grading, we might talk about tone mapping, we might talk about color space conversions and gamut mapping and all these kinds of things. And there's reasons for those having distinct words here because in a lot of these workflows they mean very specific things, and there's a huge amount of effort that goes into each and every one of those.
Mm.
But of course we're also rendering every frame individually and looking at them very
You
carefully.
have a little more time, right? Like that's one of our challenges we always ran into with real time rendering. It's like, all right, we're trying to hit at a minimum 30 frames a second, more likely 60 in a browser on a mobile device. And so
Yeah,
we have to
and
take a little liberty or cheat a little bit to make it look as good as possible.
that's exactly right. Yeah, and so when I approached the tone mapping problem and started learning about it really in real time rendering, I realized that fundamentally all of these steps and all of these words are really kind of one thing for us, because basically what we have is there's a function that takes floating point light values for our pixels colors, right? But they're colors that are unbounded. They can be as bright as the sun, and we're going to map those with a function into generally sRGB 8-bit output values. Okay. And yeah, that's a combination of things, right? Like part of that is the sRGB transfer function. Fine. Part of it is tone mapping or clamping. If you don't know what tone mapping is, it's probably clamping, but that is a tone, right?
Yeah,
Like
it's like
that's a
it's so
big
bright, we're just gonna put like all, Fs on the
distinction.
hex scale, right? So this is basically your monitor colors, right? We can only display three colors. They have a limited range of brightness, and especially in the 8-bit space, you're even there, more limited therefore as to like what the step value is between each value of those colors. Yeah.
Exactly. And so the key is, when I talk about tone mapping in real time rendering, I'm really just talking about everything. It's just like there is a function that's doing all of this, right? I usually keep the sRGB transfer function separate because that's like very well known and specified. But like
Mhm.
everything before that, it's effectively it is color grading. If there's color grading happening, it's happening in that function. You could split it into a bunch of functions if you felt like, but realistically, when we implement it, we're probably just going to cram them all back together and approximate them as a one quick
Yeah.
thing,
I mean, we got to
right?
keep it fast to your point, right? So,
Yeah,
yeah.
exactly. But the other key thing being that there that tone mapping is inevitably a big set of trade-offs, and some of those trade-offs are a big problem, and we're a big problem for the industry. That's why I started looking into this problem at Google. And so the first answer a bunch of folks had was, this is giving us so much problems. Let's just not do it. And my point was, there's no such thing as not doing it. If you
Yeah.
turn
You
off
need
tone
to
mapping,
have
all you're
some,
doing is
otherwise, you're going to have everything
yeah,
blown out, right?
you're
You add
using
a
a
little light in
clamped
there and you can't see anything.
exactly. You're using a clamped tone mapper if you're not using a tone mapper, and the clamped tone mapper is the most nonlinear of anything. People will call it linear tone mapping, but it's not. Like a linear, it's a piecewise linear thing with a hard break, and that is about as nonlinear as you can get. It introduces all kinds of hue skews, introduces all kinds of blown out artifacts, all kinds of stuff. So um, people were trying to get that to work. It does not work very well. The existing most common strategy was ACES tone mapping, or really like a particular approximation of ACS that had become really popular in real time graphics because I think
And
people
did
just
that come from
wanted.
3JS? Was that kind of like a 3JS like implementation that Model Viewer was using, or did you guys create something separate for Model Viewer?
So for model viewer, for sure, we inherited that from 3JS. But I don't think the fact that ACES is popular. I mean, it might be partly because of 3JS, but I think a lot of variety of renderers kind of were like, oh yeah, let's grab ACS. And before that, they had some other ones like Cineon and uh, uh, so yeah, some other ones that were like even less good for what we were trying to do. So I think when Aces came along, it was a standard. People were like, oh yeah, this will be great. Let's just use this. Um, and then we eventually started to find the problems with it, which is that, well, it's not really designed for 3D commerce, for product models, where we're really trying to be very persnickety about what the colors are that show through, and
And
really
I
be.
believe it was more of like a film like background, right? So maybe more familiar with like the work that you're doing today might be a little bit more relevant to that versus, yeah, commerce. To your point, we're trying to replicate a real world thing as accurate as possible, not give
Right,
it
and
style.
it's also funny because ACS tone mapping, at least the way that we were using it with sRGB renders, wasn't really what that standard was designed for at all. I mean, ACES really is a color gamut. It's designed more for translating images, and the tone mapping they developed was sort of a generic thing that I think isn't actually used all that often by film industry. Right, they're much pickier.
Okay,
They have
yeah.
their own tone mapping functions that are better anyway. And it was also more designed for working with wider gamuts. So it was like, oh, well, those colors are still reachable because maybe you're putting in inputs that are in P3 or even wider. But we are not in GLTF, at least right now, and is pretty common in real-time asset formats. We're just dealing with like JPEG, PNG images, and they're all defined, in fact, by the GLTF standard to always be in the sRGB gamut, Rec
Mhm.
709, and that's the pretty much the narrowest gamut, and that means that if you take a small gamut and then your tone mapper makes it even smaller, you end up missing a
You're
lot of color.
losing detail. Yeah.
Yeah, and that's a huge problem. And the film industry just doesn't care. So like, why would our inputs be sRGB? I was like, well, yeah, fine. If you're in film, they won't be, but for us, they are. So that was,
Yeah.
I mean, really the big insight wasn't like, oh, I can do tone mapping better than other people. Not at all. It was just that the people who are doing tone mapping have a completely different set of priorities than we had. So it was just worth basically going through the
Yeah, this is more I can do tone mapping with two arms tied behind my back and a pencil in my mouth.
process. Yeah, so I mean, what I did was, I mean, I would say it's kind of a brain dead simple tone mapper, but it's better than clamping, and it
I
works
mean, the
well
main
for
point, though,
work.
I think, is that the output is going to be visually consistent too, right? And that goes back to one of our kind of internal philosophies. Like within Khronos, we're trying to let people create content like once and then use it consistently across the board. And maybe this is actually a good time to just quickly talk about another project that you'd worked on the render fidelity comparison tool. Maybe you want to introduce that project and talk about why you made it and what it does.
Sure, I mean, really, I inherited it. My predecessor with Model Viewer built that originally, or I don't even know if it was him or other people on the team. But they started this system, and I think the idea originally, in fact, was for it to be a 3D commerce tool. It ended up being a sort of model viewer Google internal tool. It was public, but just kind of ours for quite a number of years. But eventually,
Yeah, we
we
appreciate that you eventually released it over to our Chronos Care, and we're actually working
right.
on an update that is going to be coming out probably in the next few weeks. We were just reviewing some of the
Right.
final web stuff today, and yeah, it's exciting. It's anyway. Continue.
No, that's perfect. I mean, we'd always hoped that it would be a 3D commerce kind of Chronos thing because that's absolutely the right place for it to live. The whole point is to compare different folks' renderers. And now that's happened, I think it's going to be a it's going to get sort of the attention that it needs, which is awesome. But I will say that just maintaining it as a model viewer on the model viewer side has been really useful. It's basically a huge regression test suite for model viewer, but more than that for 3JS because right model
Mhm.
viewer updates every month or two when 3JS does, and we'll pull in that thing, and of course it'll run our regressions. And nowadays it doesn't fail too often, but back in the day it would catch a lot of things. We were doing a lot of churn on the PBR shaders back there. Various
Mhm.
things would change and it would break stuff. And we would be able to immediately go alert 3JS like, hey, hold on, there's a regression in this release. We need to fix this. Um, it was really powerful, and I think it honestly encouraged 3JS to up their render regression game in their own testing. So that's all been
Yeah,
good.
and I think other teams as well, right? Like, so you have like the Babylon viewer output, you have like Wonder Cycles rendered output. I think Stella from Autodesk, like, or no, that's Dassault. But yeah, there were a number of different ones in there, right? So path traced to real time, and the idea is we basically have a grid of this same asset rendered in the same lighting. Try to get the same lighting as possible in each of these viewers. This is what a screenshot looks like. And if the thing looks different than the rest, then shame on you, go fix it, was kind of the messaging, I think, right? So that ideally all these squares look consistent across the board.
That's exactly right. And for us at Google, right? I mean, you could argue this was a little bit altruistic, but it was actually very internally helpful because the primary one that we worried about was Filament. Because of course Google has two open source real time rendering engines, right? There's
Hey,
Filament
why
and
not?
C++.
Google's got to have at least two. Yeah.
Yeah, and there's 3JS and JavaScript, right? We got lots of teams using both. Teams who need to switch back and forth between them. Having discrepancies is a huge problem, right? But they're completely unrelated code bases, right? And so having this suite of tests where we could compare them directly was incredibly useful, and it facilitated all these conversations, especially between me and Roman Guy was over maintaining, well, really the father of Filament. Um, and it was so useful because it allowed us to have much more grounded conversations in our shaders, right? Because the whole point of GLTF is like, oh, here's the physics, but actually you're going to approximate that like very seriously for to get it fast enough. There's lots of different ways to approximate it, and when you're talking about code, you can say, "Oh, I did this," and so it's like, "Well, I did that. Oh, I think mine's better. Well, this is maybe better because this." And it's like you'll never get anywhere. But when you
Yeah.
have the renders and you can be like, look, here's how mine is different than yours. And here, by the way, is how the path tracers are doing it, which are clearly doing a much better job than either of us. And look, see, mine is closer over here and yours is more different. Or like, look at this artifact. Yes, mine had more error this way, but your error is more visually noticeable or whatever, right? Like, when you have the images to see, it made it so much better to be able to say, oh, you know what, we actually we want to adopt your approximation, or no, actually, we should adopt yours, or oh, we're going to do this thing in between and see how it is. And that, I mean, it's incredible while I was there how much those renderers converged. And then it was great
Across
because
the
it
board, yeah, not just
got added
those
in,
two, but I feel like
right?
all of them.
And the other ones,
Yeah.
yeah, like as they got added in, it was just like, oh, now it's really easy to file a bug, and you just point to this link, and you can see exactly where the problem is, and like those things just got fixed, and it's been really awesome to see how that ecosystem has evolved because that's what GLTF always said, right? It's like, oh, we're going to make this render the same way everywhere because it's physically based, and people will just converge. It's like, well, this is the kind of tool, and there's more tools than this out there that have helped, but this kind of like render comparison is a key driver to actually making that happen.
Yeah, no, absolutely. And it kind of takes it back to the tone mapping conversation too, because that was one of the things I observed was how quick it actually got deployed across the most popular viewers out there, right? I was surprised because I feel like normally this stuff, like, you take time, you standardize it, you promote it. A year later, you're still like raising awareness. And in this case, it was like, I don't know, a few weeks to a month or so. And it was like, oh, actually, now the default in most of these is now using the new PBR neutral. And it was pretty
Honestly,
great to see.
that was stunning to me. That was, yeah. I mean, that was a huge highlight of my career, honestly. Like for that to have had that much adoption that quickly across the industry, I never imagined that it would go as fast as it did.
And
And
it's
it was
probably
cool.
because it was striking such a real problem, right? Like people knew they needed it, and when they saw it, it was visually clear that it was a improvement, and therefore, like, why wouldn't we implement it? Like the implementation's kind of there. Like, obviously made the algorithm available so people could incorporate it quickly. And yeah, I think the results have made an improvement for e-commerce around the world.
Thanks. Yeah, I certainly hope so. I mean, I think that's, yeah, the real key is there was a real need, right? There was definitely a gap. It was definitely a pain point. And it was interesting because I talked to so many people who had the pain point but had absolutely no idea what the source was. And it took me a good long while of digging before I figured out what the source was. And that's when I was like, oh, okay, this is, yeah, this is a worthy thing to bring, because this is not the kind of thing that you're going to like ask a random software engineer to solve, because
Yeah, I would
you're not going
agree
to
because
figure
a lot
solve
of
the
people would
rendering
just say,
problem,
"Hey,
but
it
it's not
looks
really
wrong."
the
Uh,
renderer.
it looks wrong. Okay, be more descriptive. Or like, why does it look wrong? And you really took the time to dig in and get to that answer. And yeah, I think the outcome, like I said, was very beneficial to the industry as we look towards a more consistent visual experience. And one of the things that I thought was interesting that you presented to us when we were first learning about this was that there's certain colors you just can't represent. I think canary yellow is like one of them. Do you want to talk a little bit about, the limitations perhaps of what we're trying to do?
Yeah, for sure, because they're very serious. As I say, the difficulty with tone mapping is that it is very much fundamentally a game of trade offs. There just is no way to make a tone mapper that is good for everything. And so there's a lot of things you may want in a tone mapper. I'm not even going to get into gamut mapping, which is super hard. I managed to dodge that bullet entirely because we're working in sRGB anyway. So our gamut is always
Yeah.
is fixed and it's fine. Like we don't even have to think about that, which is why my tone mapper is so simple. Um, but what we do have to worry about is bright light, right? We have to worry about shiny highlights, and we have to make those look good, look right. Um, and so the difficulty there is you want to take this thing that, like, our eyes, right, can see this incredible dynamic range of light, right? We can look from, like, the dark room behind us to the bright sun shining outside, and we can comprehend the difference in brightness across that whole range. And our monitors are, even a painter, right? Like anybody who's drawn a picture has the same problem. You want to represent a really bright thing, a really dark thing, you just can't. There is no way that you can
Yeah.
make a paint or you can make a pixel or anything as bright as the things that we see in our everyday lives, right?
Yeah,
So,
especially the sun.
right, yeah, and so, right, like every artist who's been painting or drawing on a computer or anything else since the dawn of time has had to deal with this problem. Like, I want to represent a bright thing and I can't. So, next best thing is I want to fool somebody's brain into thinking they're looking at a bright thing even though they aren't. Um, and so that's the art of tone mapping. And it's really complicated because the brain's concept of perception is really complicated. And so there's lots of really cool research and lots of crazy things that you can do. And this is the source of so many optical illusions. And like, okay, that's all great. But I said, you know what? That's all wonderful, but that's really complicated. And what we need is something simple. What our artists want is to have their 3D model show up next to a photograph of that same product on the product page, and they want those two things to look the same because if they look different,
Yeah.
people are confused, right? Rightly so. Um, and that photo probably wasn't actually a photo. It was probably photoshopped. It was probably color graded carefully after the fact to get just the colors that they think represent the product the best, because the camera couldn't even capture them accurately enough, because this is all hard.
Yeah.
And so then you're like, great. So now I'm a 3D artist. I want to make this thing the same. How do I get it to be the same color grading as whatever this like carefully doctored image is? Well, fine. I can hit it with a color picker. I get an sRGB value. How about I put that into the model? That would be nice, right? And that's exactly what
Yeah,
they're trying to
I
do.
think a
And
lot of people assume that, like, oh, the base color should match the color of the photograph. It's like, well, wait, there's all the PBR like lighting calculations that are going to impact that color, right?
exactly, right. So of course, the PBR people come back and will say, "Oh, well, of course the color is different. There's lighting. If the color was the same, you wouldn't have any shading. You wouldn't have it look like it's 3D. Like that's not what you want. You want the color to change. That's fine." And then
Mhm.
the artists come back. They're like, "No, no, 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 no. You don't understand. The color changed in the wrong way." And then
Yeah.
they would point to it carefully and they're like, look, don't you see that the hue is different? And I'm like, I know it's a lot of software engineers who are like, oh, it looks like yellow to me. I don't know. But the artists, the marketers, they can absolutely tell, right? And they're like, no, 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 no. This is not actually correct. You've lost saturation here. You've lost whatever. Like this is not representing the same color. Um, and so that was what caused me to dig into this more. And I eventually realized that like, oh, there's this tone mapping step where in fact it just takes a color in and gives you out another color, and it's actually pretty arbitrary. It's like a really complicated, 3D lookup table, and like anything could happen in there. And it turns out a lot of really weird stuff was happening in there. So like, okay, fine, well, we can get rid of that. Oh, but now you have all this problem with the perception of brightness. And so if you just clamp, it looks like garbage. It looks like artifacts. It doesn't look real because our vision in the real world is nice and continuous, right? And so if you put in a
Mhm.
hard clamp, it shows up as like a really eye-catching piece of garbage. So you can't do that. So now you have to actually do some kind of an actual mapping. You have to smoothly transition from these bright colors to less bright. And you also have to transition colored light towards more white light, because naturally, like, I mean, again, if you talk to a painter or something, right, like they'll tell you, oh, if you want to represent the bright shiny thing off of something, you paint it white. You don't paint it like saturated blue if it's a blue object, because like that's not what you see
Yeah.
as the reflection. Um, so you kind of lose some perception of that color when it gets really bright. We call that the path to white. So you need these kinds of things to make it perceptually good. um, and so I made some nice, simple, smooth functions that do that. Um, and I was trying my best to preserve as much of that color cube as I could, so that you have that round trip of like you put in your sRGB value and it comes out on the render. Obviously, it's going to be brighter or darker for shadowing, but like we can guarantee that the hue stays the same. We can guarantee some things about saturation, but you cannot make those guarantees for the whole cube. You cannot say that every single sRGB value is going to round trip, because if you did, the only solution would be to clamp.
Yeah.
It's this fundamental trade off. If you want to be able to reduce those artifacts, you also have to include unreachable colors. And so when you look at the film style tone mappings like ACES and especially AGX, people say like, oh man, if you do like an AB, it's like, man, AGX really desaturates things. And it does, but it does that because it wants to make things really free of artifacts for big high dynamic range scenes. And in a movie, that's really important. And if you're watching, Dune, and the whole thing looks kind of desaturated, it's fine. It's a bunch of sand, and you're watching in the theater. It looks great. You don't need to
Yeah.
have canary yellow in there. That's not going to improve the film, right? So like that's a really good solution. But for products, that doesn't work. And also for products, we're not dealing with sweeping sunsets. We're dealing with little bright highlights where, in fact, the artifacts are a lot less noticeable. So you can kind of crank that dial and say, oh, I'm going to accept more HDR artifacts in order to get more reachable colors.
Mhm.
And basically, all I did was play around with that balancing act until we had something that was pretty decent for our use case.
Yeah. Do you see, like, as the technology improves, obviously things get better, and are we going to see like screens that are maybe using like more of a 16-bit representation, and maybe it's not even on traditional screens, maybe it's like wearables, or futuristic technology, but it seems like it would be a big challenge to go back from all these like 8-bit maps of 3D, but maybe we'll look back in 10 years and be like, I can't believe we are dealing with such a limited range. And HDR became like a buzzword on the TV side of things for a while. And it's like, oh, we can, represent more colors now. How do you see that like evolving over time?
Right. I mean, so it's going to improve, but like fundamentally, these problems are universal. I always joke with HDR TV stuff where it's like, oh, good job. You've got an extra order of magnitude in brightness. Now you only have 8 more orders of magnitude to go to get to outdoors.
Yeah.
really good job with your HDR, but like, come on, this is like still pathetic. So, all the same stuff applies, right? This idea that's like, oh, we're in HDR, we wouldn't need tone mapping anymore is totally ridiculous. But you do need different tone mapping. So that is interesting, right? Like I made the point that what I did was for the sRGB space.
Mhm,
I think the work I did could easily be extended to other types of outputs, but it would need to be extended. I don't think you'd want to just use it blindly as is, because you'd want to make those trade offs a little differently. Um, same thing for like P3 displays. I mean, that's certainly getting more common, right? I mean, I'm looking at you on a MacBook, and it's definitely got a wider gamut that it's capable of.
mhm,
Um, in order to really make use of that, we're going to have to focus on the format side. If we don't have P3 inputs, then it really doesn't matter because we're only producing Rec 709 output anyway. So once we get around to actually authoring things in a wider gamut, then that'll be interesting. Then we'll have the hard problem of gamut mapping, of taking things that were authored in a wide gamut and stuffing them into
mm,
sRGB,
yeah.
which is another hard problem with lots of difficult trade offs. And like, there is absolutely no free lunch, absolutely no easy answer there. And it's a harder problem than the one I solved. So somebody else is going to have to deal with that. Here's literature on it, at least.
Nice. Yeah, no, I mean, it's kind of the natural cost of evolution. There's always that kind of chicken and egg scenario where, do you make the better hardware if you don't have the software to support it, or do you start making software when no one's adopted the new hardware yet? And I see that as a constant trade off, especially, I've been doing a lot of AR, VR stuff the last decade, and that's always been kind of a challenge. It's like the devices are still, not mass market, and the audience isn't really large enough to get the developers' interest. At the same time, the audience isn't going to pick up the new headsets. I think Apple really ran into this with content. It's like, it's not enough content. Why am I spending $3,500 on this thing? And then the developers are like, there's not enough users. Why am I spending time trying to make apps for it? And yeah, you just get in these natural cycles. But yeah,
Yeah, for me, I
hopefully,
feel like
we'll push
you
through
know
it.
we have like a little bit of an easier time in this like 3D commerce product space because no matter how well we're doing with 3D, um, for quite a while it's going to be enormously dominated by photographs, right? Product
Mhm.
photography is still
Yeah,
really
or even renders to match those photographs, right? You're still dealing with the same output for the most part.
sure, but it's nice because like they've got all these techniques for like color grading and doing all this stuff with Photoshop on the photos. And so I'm just like, oh, I can look at that because basically there's no reason I need to go faster than them, right? Like the job of 3D is to keep up with whatever people are doing with their like amazing manual time expensive things for Photoshop, right? And
Hmm.
so if at the end of the day the Photoshop folks are creating an sRGB PNG, then I know it's fine for me to create sRGB output. I don't have to worry about gamma yet. The minute that I start seeing product photography that's going out to websites in a wide gamut or targeting an HDR monitor or whatever, that they've put the effort in to like manually grade the stuff for those outputs, then I know it matters. And I know that we
Hmm.
can then go take care of it for 3D. There's absolutely no point in even thinking about it if the 2D folks haven't done it.
Yeah, totally. And that's a good way of thinking at it because a lot of folks are, eager to adopt new technology. But if stuff's good enough for the consumer, where we're focused on in commerce, it's really about how do you best represent the thing you're going to get so you don't return it. Right. And
Yeah,
there's, tools like, 3D models and AR that help you like identify and answer things that are maybe different from how it looks. It's more, how does it fit? What size is this thing? And then the color, that's a whole another challenge on AR, right? When you're dealing with someone's lighting on their phone and trying to mix that all together.
yeah. And I mean, again, because like the reality is there's not actually that many products that are pushing the edge of the gamut. It's like difficult to physically manufacture a paint that is that saturated, right? Like
Hmm.
people work on it hard, but it's like there are physical reasons why that's a difficult thing. So products don't tend to push the gamut that hard anyway, which is great. That makes our lives easier. Um, and then the other part of it is that like at the end of the day, everything that we do is about return on investment, right? Like, sure, making the colors a little bit better does help, and sometimes it helps a lot. Sometimes it's a very significant change that really matters. But there are going to be changes at the edges that matter less. And at that point, you really have to start thinking about the cost, right? And so a
Hmm.
huge
Yeah.
part of it is like, what about the pipelines, right? And that's why this tone mapper was all designed with the pipeline in mind, right? It has a correction for physically based rendering in it, which is a funny thing to have, right? Like, why would you correct? It's physically based.
It's
It's
already
great.
correct.
And
Yeah.
it's like, well, sure, yes, it's correct, but like what it really means is that the definition of a base color is not kind of what you'd intuitively think it is. Because we're going to render something 4% desaturated compared to that base color. Because that base color is really like what you get by measuring it with spectrometer, which is not what you
Mhm.
see, right? What you see is the output of the PBR that we're making. So there's this
Yeah, you're
correction that
working
nobody wants to
backwards.
do. Nobody wants to go and be like, oh, I guess I have to change my base color by some factor so that it actually comes out the color I want. No. So we just built that factor into the tone mapper. And it's like, yeah, it's an approximation. It's a little bit weird, but it makes the pipeline so much simpler. It makes it so much more round trippable that you can just say, like, yes, I wanted this color. I put it in. Somebody verified that triplet, and then it comes out that same triplet. Everything is fine. Like, just the ability to manage the QA in your pipeline is worth so much that it's better than trying to be slightly more physically accurate.
Yeah, yeah, that makes sense. And yeah, it reminds me of some of the comparisons we were originally trying to do when we were looking at, the output of two different images. It's like we're measuring the pixel differences between the two, but it's actually the visual perception that's more important than, what the numerical values and shifts might indicate otherwise. So
Right. And
yeah,
that's
it's a,
exactly
it's a
why I
cool
wouldn't
topic.
really worry about like 16-bit versus 8-bit, right? Because,
Hmm.
the funny thing turns out like we've been dealing with quantization errors for decades in all kinds of different fields, and we know how to handle them. It's like, oh, I'm sorry, are you quantized down too much that things are looking ugly? Just dither it. Just bounce back and forth. Add some noise. Nobody will
Maybe.
even know that you don't have this perfect, beautiful gradient, right? Like quantization is a thing you can work around, right? So when people are like, "Oh, we need our 16 bits to get this all fixed," it's like, well, no, there's plenty of other ways we can solve that problem if that's really an issue for you. I mean, think
Nice.
about the fact that like our videos that we're watching right now are compressed, and that
Hmm.
compression is like it's a complicated thing that most of us don't know how it works, but fundamentally what it's doing is quantizing the crap out of all those colors and then making them come out so we can't tell the difference. So
Yeah,
it's,
I,
it's a
I was,
doable thing.
going down that rabbit hole a few years back, and I found like it was really interesting that they prioritize green because their eyes have more, sensitivity to green. So it's like, oh, let's put more data in there, and the other channels, can have less. And yeah, there's so many different things that are happening, especially in video compression.
Right.
There's like not even dozens, probably hundreds of like patents that go into what you're watching right now. That yeah, it's kind of mind boggling, and we're just one piece of the puzzle trying to solve commerce and get stuff looking better for folks. And I think so far so good. Obviously give us your feedback. Either here in the comments or at conferences. Emmett, where can people find you?
Oh, I'm around. I mean, I suppose you could ping me on LinkedIn if you wanted to, just like if you want to chat or something. But GitHub is really where I'm most active. I have an open source project. It's my own personal thing called Manifold. If you're ever interested in some computational geometry on meshes, I'm there for you. But it's definitely where I tend to spend most of my time out on the internet, shall we say.
Excellent. Are you going to make the trek to Vancouver for SIGGRAPH this year?
Oh, that would be fun. I don't know if I'm going to be able to swing it. There's been a lot of travel already, and it's
Yeah,
a little
being
tough
on the other
leaving
side of
three
the
kids
world
at
now.
home. But yeah, we'll see how it goes. I would love to make it eventually.
All right, excellent. Well, yeah, this is really informative. I'm sure the audience appreciated the in-depth knowledge that you have, and if you're still learning all of this, there's a lot of great resources out there. We'll try to add some to the description in the video, and of course, reach out to Emmett, find him on GitHub. And thanks for watching, Emmett. Thanks for having us this week, and that's it. See you next time.
Yeah, appreciate it, Mike. See y'all.